Patran 2010. So now that I've opened Patran and I have my geometry, which in this case consists of two simple green parametric surfaces, I'll go ahead and create my finite element mesh. So under the Meshing tab, I can see that I have a variety of options. Under the Meshers section, I can do curve, to curve, surface, or solid meshing. In this case, I'll be meshing a surface, so I'll select surface, which sets my action, object, and type to create mesh surface. Because this is simple green parametric geometry, I'll be able to use my ISO mesher. So I'll select this first surface on the left. Patran comes up with a value for my global edge length, which is basically the size of the elements to be created. I could adjust this value, but I'll go with the default for now and click Apply. Because this is a 10 by 10 surface, it created elements that were 2 units in each direction. And so I have these nice square finite elements created from my geometry. So now if I want to mesh my second surface, I'll go ahead and select it. And maybe I'll use a different value for my global edge length. In this case, I'll enter 1.0. I'll click Apply, and I'll see that it created elements that had the edge length of 1.0 along this direction, but still 2 units in this direction. And that's because Patran recognized that there was congruent geometry to my second plate that already had an existing mesh on it. And in order to get a congruent mesh, you need to have nodes at the same locations. And so Patran knew that if I want a congruent mesh between these two surfaces, that I'll need to have the same spacing in this direction that I had on the already meshed surface. This brings us to the concept of generating a congruent mesh, which is really important. So if I want to verify the boundaries of my meshed surfaces, I'll, from FEM Actions, choose Verify, click Apply. I can see that this yellow line down the middle indicates that I have a free edge between my two plates. So because I meshed them separately, there are 2 separate plates that happen to just be next to each other. Now if I want them to be continuous and act as one plate with the nodes connected through the middle, what I'll need to do is equivalence the nodes. So under FEM Actions, I have the option to equivalence. And the way this works is it looks for nodes that are duplicates and coincident. So what I have is when I mesh the left plate, these elements through here have their right nodes through there. But then when I mesh the second plate, these new elements have nodes along their left edge through there, and that creates duplicate nodes. A thing to note about equivalencing is that you select the nodes to be excluded from the process. So since I want to equivalence my entire model and look for all of the duplicate nodes, I'll leave this field blank. I go ahead and click Apply, and I can see that 6 nodes were deleted, and the purple circles indicate that those were the nodes along this middle edge that's shared between my 2 plates. So now if I verify my free edges, I can click Apply and see that this is now a continuous plate between there because I equivalenced my mesh. Now I've opened a model of a more complicated piece of surface geometry. I can shade it and see that this geometry has irregular edges, holes, and has associated geometry here in this yellow curve that I want to be respected when this surface is meshed. So this will require more complicated meshing. So when I go to my Meshing tab and select Surface, this will require a paver mesher. So I'll be creating quad elements, but using a different process. So I'll select my surface, and then with the default value for global edge length, click Apply. Now you can see this is a fairly coarse mesh, but it did follow all of the irregular edges of my surface, including the associated curve here, and any nodes that were in this area it placed on this curve. So I'm going to go ahead and undo that mesh and do a little bit more work to refine and create a more sophisticated mesh here. And I'm going to start with a mesh seed. The way a mesh seed works is basically before the mesh is created, you can define where you want nodes to be created. So in this case, say I want 26 elements along this particular curve. I can select that and see that it created, with these little yellow circles, 26 points where nodes will be created. So then when I go back and mesh that surface, using the same values as before, I click apply, I can see that it created a lot more nodes in that area, a lot more elements. I can even zoom in and see that in that area, all those nodes lie right where the mesh seed told them to be created. And this is one way to force a finer mesh in this region of our plate. Other options that I have as far as meshing and creating a mesh seed are to have the spacing be non-uniform. So with a one-way biased mesh seed, say I want to create, in this case, 20 elements with a ratio of 3 to 1 for the longer spacing to the smaller spacing. And I'll do this along this left edge of the plate. I can see that I'll have much finer, or somewhat finer elements spacing down here as opposed to up here. And again, when I mesh my surface, still using the same global edge length, I click apply and I can see that that mesh seed has been respected. Now to further refine this mesh, I may decrease the global edge length to something like 0.5 and click apply and yes to delete the existing mesh from that surface. And now I can see that I've created a mesh with relatively square elements and the element spacing that I wanted, and I defined using my mesh seeds. Finally, I wanted to show that the same process applies for solid meshing. Here I've got a fairly complicated piece of solid geometry because it's got actually a hole through it, so it's got some internal geometry and irregular edges, and it shows up as a white solid in Patran. Now, when I wanted to mesh this solid, I go to meshing and choose a solid mesher, and in this case, because it's more complicated and a white solid, I'll have to choose tet mesh instead of iso mesh, which I could use if it were a simple 6-faced blue solid in Patran. In this case, I'll be using the tet mesher, and I'll create tetrahedron shaped elements, select my solid, and click apply. And I can see that it created these elements using this global edge length. Now I could use any of these additional tools in Patran to predefine the mesh with a variety of mesh seeds, or further control how I want this mesh to be created. I could also just use a smaller global edge length. In this case, I'll go to a value of 2.0, and I'll click apply and yes to delete the existing mesh. And I can see that I've got smaller, finer elements there. I could refine it even further. And then once I have the finite element mesh that I'm looking for on my part, I can continue with my finite element analysis.